So good morning all. Till yesterday we have covered Rutherford's model. Yes. Today we're going to talk about drawbacks of Rutherford model. Drawbacks of Rutherford model. Drawbacks of Rutherford. Now, two are from Arush. Arush. Ninth Blossom. Please unmute yourself, Arush. Unmute yourself fast. And please, what drawback Rutherford? Yeah. Please tell me. Yes. You know it? Yes. You don't. Ninth, awesome. Unmute yourself. Angel. Good morning, Angel beta.
Ma'am, the atomic model failed to explain the stability of atoms. It's not possible for a long run, as we know that atoms are stable while any particle in a circular orbit would undergo acceleration. And during acceleration, the charged particles will radiate energy.
Okay. So what said will around the nucleus, it will going to radiate the energy. It will going to radiate the energy, and the time will come, it will fall into the nucleus. It will fall into the nucleus, and it leads to the instability of the atom. Instability of the atom. Is it clear to you all? This is the drawback. Rutherford said, when the electron will move around the nucleus, it will radiate the energy and it will fall into the nucleus. Is it clear to you all? Yes. Now, let's move on to Bohr's model. Most important model. Bohr's model. Bohr's model. Yes. Who will going to explain me Bohr's model? Ashish. Ashish, ninth blossom. Unmute yourself beta fast. And please tell what Bohr said. Yes, beta. Okay. You can please mute yourself, beta. Ashish, your net is not working. Yash. Yash, ninth, awesome. Awesome. And please tell about Bohr's model. Okay. No. Vaishnavi. Vaishnavi, unmute yourself. unmute your. Okay. Vaishnavi, on your video. Wait. Now please see, beta. Now you can. Now you can unmute yourself. Okay. Anshika. Anshika, 9th, awesome.
Good morning, ma'am.
Yeah, good morning, beta. Please tell beta.
Yes, ma'am.
Yes.
Ma'am, Neil Bohr said that when the electrons will revolve in the orbits, first of all, they will revolve in special kind of orbits, shells or discrete orbits. And when they will revolve in these orbits, they will not generate any kind of energy. And ma'am, these orbits are given the names as KLMN and this one, ma'am, and mean like a specific number of electrons can only be fitted into these orbits.
Yes. Please note it down. What Bohr said that electron will only revolve in a discrete orbits, in a specified orbits. Is it clear to you? They will going to revolve around the nucleus in the discrete orbits, and when they will going to revolve around the discrete orbit, they will not going to radiate the energy. Electrons will not going to radiate the energy while revolving in a discrete orbit. But when electron will move from one shell to another shell, when electron will move from one shell to another shell, they will going to absorb energy, absorb or radiate the energy. Nikhil, 9th, awesome. Please tell when electron will going to absorb the energy and when they will going to radiate the energy. Nikhil, I can't find you. Anurag Notial. Please unmute yourself, Anurag.
Yes, ma'am. Good morning, ma'am.
Yes, beta. Please tell when they will going to absorb the energy and when electron will going to radiate the energy.
Ma'am, when they will donate, then they will radiate energy, and when they will lose, when they will gain, then they will lose energy.
But
Electrons.
no. Gun. Gun, 9th, blossom. Unmute yourself. Yes, beta.
Ma'am, when they are revolving in the discrete orbit, the electron do not radiate energy.
I'm asking, said electron one shell, they will radiate or absorb the energy. My question is, when electron will going to radiate the energy and when it will going to absorb the energy?
Ma'am, when it will gain, then it will absorb, and when it will lose, then it will radiate.
What gain and what lose?
Electrons.
Latika. 9th, awesome. Yes, beta. Good morning.
Ma'am, when electrons are revolving in discrete orbits, when they will lose the electrons, then they will radiate the energy. When they will gain the electrons, then they will absorb the energy.
Okay. Now please tell me, when electron is moving from lower shell to higher shell, lower to high, low to high, okay, then it will going to radiate the energy, absorb the energy. From low to higher level, they will going to radiate it or they will going to absorb the energy.
Ma'am, they will radiate the energy.
From low to higher.
Yes, ma'am.
Okay. And when they will going to come from high to low, they are jumping from high to low.
Then they will energy.
Will absorb it. Shubh, 9th, awesome.
Good morning,
Unmute
ma'am.
yourself. Good morning, beta. Yes. Beta, tell. Electron is jumping from low level to higher level. Low to high. They will going to absorb the energy or they will going to radiate it.
They are going to absorb energy.
Low to
High.
high. See, students, when the electron will going to move from low to high, lower level to higher level, they will going to absorb the energy. You are getting my point? Like when we are doing, when we are also going from low level to high level, so we need to absorb the energy. We can put the and when the electron is jumping from high to low, no, now we are coming from high to low. They are going to
lose energy.
They will going to lose the energy. Please note it down. Please note it down. Yes. So when the electron is moving from low to high, they will going to absorb the energy. High will going to be. Is it clear to you all? So Bohr said that electron will going to move only in the discrete orbit, and when they are moving in the discrete orbit, they will not going to radiate the energy. They will not going to radiate the energy. When electron will move from one level to higher level, then they will going to radiate the energy. Is it clear to you all? These orbits were named as K, L, M, and N shell. K, L, M, and N shell. The value of N for K is 1, for L it is 2, for M it is 3, and for N it is 4. I hope it is clear to you all. My next question is from Nikhil, 9th Blossom. Nikhil, 9th Blossom. Unmute yourself, Nikhil. And please tell, what do you mean by orbit? What do you mean by orbit? Unmute yourself. You know it? Sonal.
Good morning, ma'am.
Yeah. Beta, please tell, what do you mean by orbit?
These are shells in which electrons revolve.
These are the shells in which electron revolve. Means we can say the circular path. We can say these are known as orbit. The circular path in which the electron revolve are known as orbit.
Orbit.
Is it clear to you?
Yes, ma'am.
Sanskriti, 9th, awesome. Unmute yourself.
Good morning, ma'am.
Good morning, beta. So this was said by Bohr. I hope it is clear to you. My next question is, who has given the scheme distribution of electron. Distribution of electron. Electrons in the shell. Who has given this?
Ma'am, Bohar and Bury.
Bohar and Bury. Amazing, Sanskriti. Bohar and Bury has given the scheme of distribution of electron in the shell. Beta, how? How?
In first shell, 2 electrons can be taken, and in second, 4. In second, third, and fourth, 8 electrons can be taken.
Okay, no, this is not the answer of my question. Vedant. What you said?
Morning, ma'am.
Yes, beta.
Good morning, ma'am.
Yeah, good morning, beta. Please tell beta.
They gave the formula 2n square.
The maximum accommodate in any shell, they can be given by the formula 2n square.
Square.
Please mark it as star. Square. Electron Vedant in K shell accommodate
2.
2. How? For K shell, the
And value will be
of
1.
n is 1. Very good, beta. So 2, 1 square is equals to 2. Yes. Now for L shell,
8.
8 electron. Very good. How? For L shell, the value of n is 2.
2.
So it will be 8.
8.
For N shell,
18.
18. Amazing. How? For M shell, the value of n is 2.
3.
Yeah, sorry, 3. Yeah. Then for N shell,
32.
32. Very good. For N shell, the value of n is 4. It will be equals to 32. Is it clear to you all?
Yes, ma'am.
Yes. Okay. So at last, I will going to show one picture to you of Bohr's model. Yes, I hope the picture is clear to you all.
Yes, ma'am.
So you all can see in the center, nucleus is present and K, L, M, N. The value of n is, and for n, the value of n is 3. I hope this model is clear to you all. Is it clear? This is the model which is given by Bohr. Yes. Okay, beta. Okay. Yes, Arush. Arush is having a doubt. Arush, 9th blossom. Yes, beta, speak.
Ma'am, you can explain one thing.
Yes.
Ma'am, if electron it have nucleus, then why?
Rutherford, you can mute yourself first. What Rutherford said, that when electron will revolve around the nucleus, it will going to radiate the energy. Electron will going to radiate the energy, and the time will come, it will fall into the nucleus. It will fall into nucleus. Electron will going to nucleus, then the atom will burst. Okay, so this was the limitation of Rutherford. Then what Bohr said when electron will going to revolve around the nucleus, they will revolve only in the discrete orbit. Only in the discrete orbit. And when they are revolving in the discrete orbit, they will not going to radiate the energy. When they are revolving in a discrete orbit, in this orbit, they will not going to energy. They will only going to absorb and radiate when they will move from higher level to lower level or low to high. Is it clear to you now? Yes. Okay, beta. Okay. So I hope this Bohr and Urey scheme is clear to you all. Is it clear to you all? Again, I'm showing one more of Bohr and Urey scheme. Please, everyone, note it down in your notebook. Yes, I hope the picture is clear to you all. Please, everyone, note it down in your notebooks that for K share, the value of N is 1 and the maximum electron that can accommodate in K shell, that is 2. And in L, the value maximum electron is for M shell, N is 3. Maximum electron can accommodate, it is 18. And for N shell, the value of N is 4 and maximum electron can accommodate, it is 32. I hope you all have noted down. Now, any confusion till here? Bohr-Bury scheme? Yes, Ayushi. Yes, beta Ayushi.
Good morning, ma'am.
Good morning, beta. Yes, beta.
Ma'am, I understood.
Okay. Okay, you can mute yourself, beta.
Okay, ma'am.
Let's move on concept, that is valency. Valency or valence electron. Valency or valence electron. Shaurya. Shaurya. 9th Florence. Unmute yourself and please tell me valence yourself. Do you know? Yeah. Okay, you don't know? Karan. Karan, 9th Florence. Karan, 9th Florence. Unmute yourself and please tell what do you mean by valence electron?
Ma'am, tendency to lose or gain electron.
Valence electrons, I'm asking, beta. I'm not asking you valency. What do you mean by valence electron? Yes, Anprit. Unmute and tell. Good morning, beta. Yes, tell, beta.
Ma'am, the electron present in the outermost shell of an atom is called valency.
Very good. The electron present in the outermost shell, like this is the structure. Sanprit, please tell what is the outermost shell for this structure? Structure number 1. Only K shell is present.
Yes, ma'am.
In this structure, K shell and L shell is present.
L is the outermost.
And in this structure, M is the shell. In this, please tell what is the outermost shell?
K.
K. Very good. In this
L.
what is the
M.
outermost shell? M. So the electron present in the outermost shell will be known as valence electrons. Will be known as valence electrons. You can mute yourself, beta. Now let's talk about valency. What do you mean by valency? What do you mean by valency? Kanika. Kanika.
Good morning.
Good morning, Kanika. What do you mean by valency?
Valency is the combining capacity of an atom.
Very good.
Of
Valency is the combining capacity of an atom. Is it clear to you all? Combining capacity of an atom. Yes. Now everyone, please note down one question. And one question. How many valence electrons are present in how many valence present in chlorine? First. Very good. Amazing. Amazing. No gun. Bhavya, ninth blossom. Unmute yourself. Very good. Very blossom. Mute. Vansh.
Good morning, ma'am.
Yeah. Yes, Bhavya. How many valence electrons are present in chlorine?
7, ma'am.
7. How better?
Ma'am, because in its outermost shell, 7 electrons are there.
What is the atomic number of chlorine?
17.
17 is the atomic number of chlorine. Now let's try electronic configuration. It will be
287.
287. What is the outermost shell?
7.
7. So the electron present in the outermost shell will be the valence electron, and in this, how many electrons are present in the outermost shell? That is 7.
7.
My next question is from Shreya. Shreya, please tell the depth electron.
It is known as the distribution of electrons in a particular shell.
It is the
Distribution of electrons,
distribution of electrons in a
particular shell.
shells. Is it clear to you?
Yes, ma'am.
Distribution of electrons in a shell is known as electronic configuration. Okay. Please importance which you need to note it down. Now my next question is, please write everyone. Next question. Draw the atomic structure of magnesium. Draw the atomic structure of magnesium. First, now it atomic structure. Draw the atomic structure of magnesium. Please show in your cameras your notebook. Fast. Those who have drawn, please show the notebook in your camera. Go on. Please. Very good. Amazing. Ansh Narwal, show fast. Shore, show your notebook. Fast. Very good. Sanskriti. Very good, Latika. Very good, Nikhil. Amazing. Very structure. Vansh, please show your notebook. Tejaswini, show it fast. Very good, Ashish. Very good. Ashutosh, see your electrons are lying too close to each other. Electrons, see, the structure should be, this is nucleus. First is the that is, so the integration is 282. We need to draw 3 shells, K, L, M. This is nucleus, K shell, L, and this is M. Okay, in K shell, how many electrons we need to keep? 2. So 1 and 2.